Somebody once told me the world is gonna roll me. I ain't the sharpest tool in the shed.
Okay, so we're going to talk about the converse to the Pythagorean theorem. I need you to remember that the side length of c in a squared plus b squared equals c squared is always the hypotenuse of the right triangle. So here we have a few triangles, and we want to determine, are they right triangles? And we do that by taking the numbers and putting them into that formula. And if the formula works and it's true, then it is a right triangle. If it does not work and it creates an equation that is not true, then it is not a right triangle. The only thing that I need you to do is remember that your smallest number is going to be substituted for A, and your biggest number will be substituted for C, so the middle number is going to be substituted for B. And this is what it looks like on number 7. You have A squared plus B squared equals C squared. We substitute those numbers in for their variables, and this is where that perfect squares list comes in handy. So we get 64 plus 225 equals 289, and that is a true statement. So even though this does not look like a right triangle, it is one, based solely on the side lengths. Go ahead and try to at least set up the equation for number 8. See if you can place the variables in the correct, or the numbers in the correct location. So we have a squared plus b squared equals z squared. Remember, your lowest number is always a, so we get a squared plus 24 squared equals 25 squared. 25 is the hypotenuse in this case and would be your c squared. When you multiply those, when you do the powers of 2 there, you multiply that out and add together, you get 625 equals 625. That is a true statement. So even though this does not look like it, it is still a right triangle. We are into the part of geometry where you cannot just look at a triangle and think you know what it looks like. You have to be able to prove it. So with the Pythagorean theorem, we are able to prove this is a right triangle, even if the artist is not very good at drawing right angles. Go ahead on number 9 and see if you can place those side lengths in the correct order. So we get a squared plus b squared equals c squared, which is 6 squared plus 7 squared equals 8 squared. We square all those numbers and add together, and we end up with 85 equals 64. That is not a true statement, so this is not a right triangle. Even though it looks like it is one, it's not. Okay, try number 10. So we get a squared plus b squared equals c squared. 8 squared plus 10 squared equals 14 squared. 64 plus 100 equals 196. 164 equals 196. That is not a true statement, so this is not a right triangle. Go ahead and start on number 11. Okay, so we get a squared plus b squared equals c squared. 9 squared plus 40 squared equals 41 squared. 81 plus 1600 equals 1681. When you add those together, you get 1681. This is true, so this is a right triangle. even though it does not look like one. Go ahead and try number 12. So we have a squared plus b squared equals c squared. 6 squared plus 8 squared equals 10 squared. When we square those, we get 36 plus 64 equals 100. And that works on both sides, so this is a right triangle. So we are using this theorem to determine if the triangles are drawn correctly. Go ahead and try these. You can pause the video here. I'm not going to give you the answers yet. You'll get those when I get back, and you can work with your table. So you'll need to work those. You also need to work these. And this right here. This is just a simple yes or no. Is it a right triangle or not?